Cambridge IGCSE, May-June 2021, 0625, paper 23. Before going to the solutions, if you find this video useful, please subscribe my channel and like this video. Question 1. The diagram shows a plastic rod alongside a ruler. What is the length of the rod? In order to check the length of the rod, first we need to know how much one division represents. So we can see in between the numbers given on the ruler, initially it is 0, then 10. In between 0 and 10 there are 5 divisions. 1, 2, 3, 4, 5 divisions are there. So we can check what will be the length of one division. Or we can find the length represented by one division is equal to the total length in between these 2 points, that is 10 centimeter, over the number of divisions. There are 5 divisions. So we will get 2 centimeter. So from this we can understand one division in this given ruler represent 2 centimeter. So this is represents 2 centimeter, then 4, 6, 8, 10. Next we can measure the length of the plastic rod. So its initial point starts from 2 and final end or the other end touches exactly in between 8 and 10. That means that should be representing 9, the value between 8 and 9. So the length of the plastic rod is exactly in between 2 and 9. Starting from 2 and ends in 9. Therefore, the length of this plastic rod will be the difference of 9 and 2. So that is 7. That means the length is 7 centimeter. Correct answer is option C. Question 2. 4 balls with different masses are dropped from the height shown. A resistance may be ignored. Which ball has the smallest average speed? So we have 4 different balls. They are having different masses. That is one important point we have to check. The balls with different masses. And by looking at this figure we can understand they are falling from different heights also. So the balls with different mass and falling from different heights. And we need to check which ball has the smallest average speed. So for these balls, masses are different and the distance covered also different. So these 2 factors are different for different balls. So we need to check what will happen if the mass and distance changed. How it will affect the average speed. So first we can focus on the mass. When mass changes, how it will affect the average speed. So here we have different balls. They are falling under gravity. There is no air resistance that is mentioned in the question as air resistance may be ignored. So there is only force acting on this ball is the force due to gravity or the weight of the ball. So we can understand the net force or the resultant force or only force acting is weight. And we have the equation of force F is equal to ma, and we have the equation of weight, that is W is equal to mg. So you can write the equation, same equation, in terms of instead of F you can write ma, instead of weight W you can write mg. Now look at the equation. You can see that mass is common at both sides, so we can cancel. Then you will get acceleration of these free falling balls is nothing but g value. G is acceleration due to gravity or gravitational field strength. So that is 10 meter per second square. So this is one important point we should understand, that for all the balls its acceleration is constant and that is 10 meter per second square. Doesn't matter the ball is massive or lighter, its acceleration will be always 10 meter per second square. From this you can understand acceleration is not depending on the masses. So for all these 4 balls, the acceleration is 10 meter per second square. For the second ball also acceleration is 10 meter per second square. For the third ball also acceleration is 10 meter per second square. Even for the final ball is also its acceleration is 10 meter per second square. So from this we can conclude very important point: mass does not affect the acceleration of a free falling object. It will be always g, that will be 10 meter per second square. So we realize mass is not going to affect. Next, the factor which is different for all the balls are its falling distance, and we can see it is increasing when the balls options moving from A to D. So now we need to check whether the distance falling has any effect on the speed. So here we have seen there is an acceleration for all the objects or all the balls as they are free falling, and all the balls are under a acceleration due to gravity, and that value is 10 meter per second square. So that means we need to understand all the balls are accelerating, or accelerating means speed is keep increasing. Or for every second square its speed is increasing 10 meter. Then we can understand when the distance increased. When distance increase, what will happen? The ball will take more time. Time will be more. Time taken to fall will be definitely more because the ball has to travel more distance. So when time is more, the balls will get more times to accelerate, or more acceleration will be there. So more acceleration means the ball will reach a more speed at the end. So the ball which is falling from more distance will have more speed. Likewise, the ball which is traveling less distance will have less average speed. So here we need to find which ball has the smallest average speed. In order to find smallest average speed, we can understand the ball which travel smallest distance or less distance will have less average speed. So by looking at the option, we can see that option A, ball in option A is traveling less distance, so less time to accelerate speed. Therefore the correct answer is option A. Question 3. A cyclist rides 300 meters up a slope in 50 seconds. She then rides down the slope in 25 seconds. So we can imagine there is a slope. And initially the cyclist rides 300 meters up a slope. So the length of the slope is 300 meters. She is initially moving upward, so traveling 300 meters. Then she rides down. Then she coming back. So again she has to travel 300 meters. So the total distance travelled. The distance to go up plus the distance when she come down, that is 300 plus 300. So it will be 600. So total distance she travelled is 600 meters. Now we can check what is the total time taken. So she took 50 seconds to go up the slope and 25 seconds to come down the slope. So the total time taken is 75 seconds. So we can calculate the average speed. We need to just use the equation of average speed. Average speed equation is the total distance travelled over total time taken. So the total distance is 600 meters over total time taken is 75 seconds. So we will get 8 meters per second. So that is the average speed of the cyclist. Therefore the correct answer is option B. Question 4. An object is on the surface of Earth. Which statement describes the weight of the objects? Let's see each options. Option A, the quantity of material that an object contains. That is mass, not weight. Mass means the amount of matter or the quantity of material. So option A actually represents mass. Option B says the quantity of space that the object takes up, and the quantity of space represents its volume, not weight again. Option C says the gravitational force acting on the object, and that is correct. The gravitational force acting on an object is nothing but its weight. Therefore, correct answer is option C. Question 5. The tank shown has the dimension 5 meter, 4 meter and 4 meter. It is completely filled with water of density 1000 kilogram per meter cube. What is the mass of water in the tank? So here we can use the equation of density. So density is mass over volume. But here we need to calculate mass. So in order to calculate mass, we can rearrange the equation and we can make mass as the subject. So we will get mass is equal to density and volume will go to the left hand side of the equation. So from denominator, volume will go to the numerator. So it will become multiplication. We have the value of density which is given, so we can directly substitute. But instead of volume, we are provided with the length, breadth and height of this cuboid. So if you know the length, breadth and height, the volume can be calculated using the equation volume is LBH, length times breadth times height. So here instead of volume you can write that will be the product of length times breadth times height. We are provided with length, breadth and height, so we can substitute all the values. So initially density, that is 1000, times length is 4, times breadth is again 4 and height is 5. We can multiply all the values. So we will get 80,000. As its unit mass, the unit is kilogram. So therefore the correct answer is option D. Question number 6. This is from Hooke's law. The extension load graph for a spring is shown. The unstretched length of the spring is 17 centimeter. When an object is suspended from the spring, the length of the spring is 19.2 centimeter. What is the weight of the object? So in this question we have a spring and the unstretched length of the spring is 17 centimeter, or the original length of the spring without hanging any mass is given, and that is 17 centimeter. Once an object is suspended, definitely we know that the spring will extend. So this is the new object suspended. As a result, the spring extended to a new length, and that new length is 19.2 centimeter. And using this information, we need to find out what is the weight of this object or the load of this object. So we are provided with the extension load graph. So by finding what is the extension of this spring when we subtended the object, and by checking the corresponding load for this extension from the graph, we can find out the load or the weight of the object. So the initial step we need to do is find the extension of the spring, or how much the spring has extended when we suspend the object. So we can calculate that by subtracting the new length or the extended length minus the original length. So we will get 2.2 centimeter, that is the extension. So now we can use the graph and check where is the extension 2.2 represents. So on y axis we have extension, where we can check which point represent 2.2 and this point represent 2.2. So for this 2.2 extension, we can find what is the corresponding load by checking the x-axis. So we can extend this 2.2 on y-axis and check at which point which is connecting with on x-axis. So we can understand that represent 3 Newton. That means this object must have a load or weight 3 Newton. Therefore the correct answer is option D, 3 Newton. Question 7. A car of mass 1200 kg is traveling along a horizontal road. The total frictional force acting on the car is 1000 Newton and the driving force is 4000 Newton. What is the acceleration of the car? So here we are provided with the mass and different forces acting on the car. So there are two forces acting in opposite directions. So we need to calculate the net force acting and we just need to subtract both the forces as they are acting in opposite direction. So 4000 minus 1000. So we will get 3000 Newton forward force in the direction of the driving force, as the driving force is greater than the frictional force, the resultant force in the direction of the driving force. So we have the net force acting on the car is 3000 Newton, mass also we have. So in order to calculate acceleration, we can use the equation F is equal to ma, where we need to calculate acceleration. So make acceleration as the subject, so we will get acceleration is equal to F over m. When m go to the other side, it will go to the denominator. Now we can substitute the values. The net force is 3000 Newton over the mass is 1200 and the answer is 2.5 meter per second square. Therefore the correct answer is option C. Question 8. Object X moves to the right along a frictionless surface towards a stationary object Y as shown. They make a noise as they collide and then both objects move to the right. Which equation is correct? So this question is based on the conservation of momentum. So there is a collision happening, but before collision, let's see. Before collision, object X is moving towards right, but object Y is stationary or at rest. That means the velocity of Y, initial velocity of Y is 0. Uy is nothing but initial velocity of Y, object Y. We can represent that as Uy, which is 0, as it is at rest. As the velocity of Y is 0, its momentum, initial momentum of Y also will be 0, as momentum is the product of mass into velocity, where velocity is 0, so mass times 0, so we will get momentum is also 0. So 0 is the initial momentum of object Y as it is not moving, but X is moving, so it will have a momentum and its momentum will be its or initial momentum or momentum of X before collision is the mass of X times initial velocity of X. So we have before collision what is the momentum of object X and what is the momentum of object Y. Momentum of object Y is 0, but momentum of object X is there. So we can find out what is the total momentum of both X and Y before collision. That will be momentum of X before collision plus momentum of Y. but momentum of y before collision is 0. So we can simply write the total momentum before collision is simply the momentum of x before collision. As momentum of y is 0, we don't need to include that. So this is the first point we can conclude about this particular question, that is the before collision the total momentum is only the momentum of object x. Now we can focus on the total momentum after collision. So we need to find what is the momentum of x after collision, then what is the momentum of y after collision. And in the question it is mentioned that after collision both object moves to the right. So both the object will have velocity and momentum. So we can write after the collision object x will have a momentum and even object y will also have momentum as both the objects are moving. So the total momentum after collision is equal to the momentum of x after collision plus momentum of y after collision. So this is the total momentum after collision, that is the momentum of x after collision plus momentum of y after collision. Likewise we have the total momentum before collision. Now according to the conservation of momentum, we know that the total momentum before collision must be equal to total momentum after collision. Therefore the total momentum before collision, we know that that is only the momentum of x before collision, that must be equal to the sum of the momentum of x and momentum of y after collision, and which is given in option D. The momentum of x before collision is equal to momentum of x and momentum of y after collision. So correct answer is option D. Question number 9. A stream flows out of a lake and down the side of hill. What best describes the change in energy stores? So we have a hill and the top of the hill there is a lake and the water is falling downwards. So we need to change the change in energy stores in this flow of lake. So at the top of the hill, as the height is more from the ground, the water will have gravitational potential energy, but while it is falling downwards, the gravitational potential energy will convert into kinetic energy as it's moving. So the energy associated with the movement is kinetic potential energy. So we can conclude that this gravitational potential energy will convert to kinetic energy, and some of the energy will be in the form of internal energy too. So internal energy is simply the energy associated with the particles inside the water. So all the gravitational potential energy will convert to kinetic energy and remaining will be in the form of internal energy. So therefore the correct answer is option B. So here internal energy is mainly when the water falls, there will be some friction. Because of the friction, the water molecules will gain some thermal energy. So their thermal energy increases, that is internal energy. So basically we can conclude that all the gravitational potential energy will convert to kinetic energy and some other form of energy lost in the form of thermal energy. Question 10. The energy input to a device is E. The amount of energy wasted by the device is W. Which expression gives the efficiency of the device? So we have a device and the total input energy we are providing to this device, that is the input energy, is represented by E. So E is the total input energy giving to this device, Out of this input energy, total input energy, some of the energy has lost in the form of waste energy. So some energy has lost in the form of waste energy that we can represent it by W, and only the remaining energy we can, or the device is using as a useful energy. So the remaining energy will be the total input energy minus the energy wasted. That will be the useful energy, or the remaining energy which is useful for the device to work. So this is the important point you should know, that the total energy is E. Out of E, some of the energy is wasted and the remaining energy is only getting as the useful energy output. Now we need to check which expression gives the efficiency of the device. So let's look at the equation of the efficiency of the device. Efficiency is equal to useful output energy over total input energy times 100. So we have the values of useful output energy, that is E minus W. So we can write useful output energy E minus W over total input energy. So the total input energy is simply E times 100. This is the equation of efficiency. Therefore the correct answer is option C. Question number 11. A builder lifts 30 bricks from the ground onto a platform 2 meter height. Each brick has a mass of 4 kg. What is the work done against gravity by the builder in lifting the brick onto the platform? So here we can use the equation of work done, that is equal to force times distance. Here force is nothing but weight of the 30 bricks times the distance travelled by the bricks. So weight is nothing but mass times gravitational field strength times distance. So we can find out what is the weight of 30 bricks. So mass times G is weight, where mass is 4 times G value is 10, but this is the weight of one single brick, but we have such 30 bricks, so you should multiply that with 30, then only we will get the weight of 30 such bricks times the height is 2. So we can simply substitute all these values and find the answer. And the answer is 2400 joule. Therefore, the correct answer is option D. Question 12. A book has a mass of 400 gram. So the mass is provided. The surface of the book is in contact with the table, has a dimension 0.10 meter times 0.20 meter. So length and breadth is also provided. The gravitational field strength is 10 Newton per kg. G value is given. What is the pressure exerted on the table due to the book? So here we can use the equation of pressure, that is force over area. So force is nothing but weight of this book times area, where weight equation we can again rewrite as W. Instead of W we can write W is equal to mg. So instead of W I am writing mg over area of this table which is in contact will be length times breadth. So we are provided with the length and breadth separately. Now we can substitute the values, but we should check that the unit of mass in kilogram, but here it is given in gram. So 400 gram you should convert into kilogram. In order to convert from gram to kilogram, you should divide the value with 1000. So we will get 0.40 kilogram. So 400 gram we have converted into kilogram by dividing with 1000. Now we can substitute the values. So mass of this book in kilogram is 0.4 times G value is 10 over length times breadth. Length is 0.10 times breadth is 0.20. And the answer is 200. The pressure is force over area, so Newton over meter square. Therefore, the correct answer is option D. Question 13. The diagram shows a tank full of water. The mass of the water in the tank is m. The density of the water is rho. The height of the water in the tank is h. Which equation gives the pressure P due to the water at the bottom of the tank? So we need to find what will be the pressure exerted by the water at the bottom. So here we have to use the equation of pressure in fluid, that is rho GH, where rho is the density of that fluid, G is gravitational field strength, and height is the depth of the liquid. Therefore, the correct answer is option A. Question 14. A liquid at room temperature is put on a metal surface which is also at room temperature. A student blows gently across the liquid and its temperature decreases. What causes liquid to become cooler? This question is from the concept evaporation. So we have a metal surface and on this metal surface a liquid is put. So imagine this is the liquid which we have kept on the metal surface, and a student blows gently across the liquid. So a student blows gently, so the air will move on the surface of the liquid. So let's see what will happen to the liquid. As we know, there is a blow of air. It's similar to wind, which will support the process of evaporation, so that the lots of liquid molecules will escape to the air, and these liquid molecules will have more energy, so that more energy particles will escape to the air, so the remaining energy of the liquid will reduce, as high energy liquid particles already escaped from the liquid. This is the process of evaporation. That's why the total energy or the total temperature of the remaining liquid will reduce. So the liquid will become cooler. The same question is asked here. What causes the liquid to become cooler? So we can see option D is correct. So the more energetic particles in the liquid escape into the air. Therefore the correct answer is option D. Question 15. Very small pollen grains are suspended in water. A bright light shines from the side. When looked at through a microscope, small specks of light are seen to be moving in random jerky manner. What are the moving specks of light? So this question is about Brownian motion. So through microscope, if we look, we can see the pollen grains moving. We cannot see molecules of the liquid. That is the most important point you should know. Even though we are using through microscope, we can't see the molecules as their size is too small. We can't see molecules. We can see only pollen grains. Can be seen. It is because the size of the pollen grain are much greater comparing to the size of the molecules, so that we can see them with the help of this arrangement. So in this question, he can see small specks of light are seen, means that is nothing but pollen grains. So we have to identify what are the moving specks of light. Pollen grains being hit by pollen grains. So we already discussed these particles which is moving, he can see is pollen grains, not the molecules of the liquid, as molecules of the liquid are too small to see even through microscope. So they are pollen grains. But why these pollen grains are moving in a zigzag manner? It is because the small molecules inside this liquid, even though which we cannot see through the microscope, they are there and they will be moving in random direction with very high speed. So the molecules in the liquid will be moving randomly with high speed, will hit the pollen grains. So because of these pollen grains are moving in random direction. So the reason is these pollen grains are being hit by randomly moving liquid molecules with very high speed. They hit the pollen grains, so that the pollen grains also moving in random direction. So we can conclude, we can see only pollen grains but being hit by not other pollen grains but other water molecules. So pollen grains being hit by water molecules is the correct answer. Option C says he can see the water molecules. But that is wrong. Water molecules are too small. So we can't even see through a microscope. So the water molecules, this is wrong. And here this all other pollen grains are hitting, that is also wrong. So the correct answer is option B. A student calculates the energy needed to rise the temperature of aluminium block from 50 degree to 60 degree Celsius. He then does an experiment to measure the energy used to do this. Which statement about the measured energy is incorrect? So there is an aluminium block. In order to increase its temperature from 50 degrees Celsius to 60 degrees Celsius, how much thermal energy should supply to this system? So this is what the student is calculating. So there is an equation we can use. The thermal energy required in order to increase the temperature of this aluminium block is the mass of the aluminium block times specific heat capacity of this aluminium block times the change in temperature. So in order to have a temperature change from 50 degree to 60 degree, the student should apply a heat energy this much. But when we doing this experiment, some of the thermal energy which is transferring to the aluminium block will be lost to the surrounding. So actually the thermal energy is supplied not only using to increase the temperature from 50 degrees Celsius to 60 degrees Celsius, but some of the energy is also consuming or wasted into the surroundings. So the child must have used energy which is even more than the temperature that just required to increase its temperature 50 to 60, because some of the additional energy has lost it to the surrounding. Now we can see which statement about the measured energy is correct. So we already concluded the measured energy is something greater than the energy just required to change the temperature from 50 to 60, as some energy has lost to the surrounding. So option A says the measured energy will be greater, that is correct, than the calculated energy because some energy is transferred to the surrounding. Yes, option A is correct. Question number 18. Which row correctly describes a liquid that is boiling? First column says about the bubble scene. In the process of boiling, there will be bubbles formed. Therefore, option A and C says, or A and B says there is no bubble scene. That is wrong. And the second column says where it takes place in the liquid. And boiling is the process which takes place throughout the liquid. It's not like evaporation. Evaporation is a phenomenon which will take place only at the surface. But here we are saying about boiling. This is a process which will occur throughout the liquid. Therefore, the correct answer is option D. Question 19. Three students are planning an experiment to test thermal conduction in different materials. The students each propose a hypothesis. 1. I think the copper rod will be a good thermal conductor because it is a metal. 2. I think the glass rod will be a good thermal conductor because it has free electrons which vibrates and transfer energy quickly. 3. I think the wooden rod will be a poor thermal conductor because it can only transfer energy along the rod by vibrating the lattice particles. Which of the hypotheses are correct? So we can check each hypothesis. First, student said, I think the copper rod will be a good thermal conductor because it is a metal. Yes, metal is a very good thermal conductor as it consists of lots of free electrons. They can easily move from one side to another side. So these free electrons will transfer or carry heat energy from the hot side to cold side easily. Therefore, first hypothesis is correct. Second student says, I think the glass rod will be a good thermal conductor because it has free electrons. That is wrong. A glass rod is an insulator or it does not contain free electrons. So the second student's hypothesis is wrong. Let's check the third student's hypothesis. I think the wooden rod will be a poor thermal conductor because it can only transfer energy along the rod by vibrating the lattice particles. That is correct. In wood, the thermal energy will transfer from one side to another side only because of vibration of the lattice particle. One vibration will cause the neighboring particle to vibrate, which will continue to the other end. So slowly the heat will transfer. That is the only way through a wood the heat will transfer. The second way the heat transfer is through the free electrons, but in a wood there is no free electrons as it is a good insulator. We know that. As we mentioned about glass, in wood also there is no free electrons available. So due to the movement of free electrons, heat is not going to transfer. So the only way the heat transfer in a wood is due to the vibrating the lattice particles. Therefore, third hypothesis is also correct and the correct answer is option B, 1 and 3 only. Question 20. A copper plate is shiny on one side and is painted dull black on the other side. The plate is heated to a high temperature. A person places his hands at equal distance from either side of the plate, close to the plate but not touching it. Why does the hand near the dull black surface of the plate feel much hotter than the hand near the shiny surface? So, the hand near the dull black feel much hotter. So, what could be the reason? Here this copper plate is heated to a very high temperature. That is already mentioned. The copper plate will have a very high temperature and the hand next to the dull black is getting much hotter than the hand near the shiny surface. That means there must be more heat waves transferring from the metal plate to the hand from the dull black surface comparing to the shiny surface. At the side of shiny surface there must be a less transfer of heat energy from the metal plate to the hand. This is what we can conclude. And the reason for this is dull black emits more thermal energy than a shiny surface. So that's why more thermal waves are traveling to the hand next to the dull black. So the shiny surface emits less heat energy or heat waves. That is a property. Now we can see the options. Option A says the dull black surface is a better emitter of radiation than shiny surface. Yes, that is a correct answer. Anyway, we can see the other options. Option B says the dull black surface is a better conductor of radiation than the shiny surface. The statement is correct. It is a better conductor. It can be, but here the reason why the hand next to the dull black feel much hotter is the reason is the rays, heat rays emitting from the dull black surface. So we should only focusing about the emitting properties, not about the conduction or reflection, which is mentioned in option C. And let's say option D. Option D says the dull black surface is at high temperature than the shiny surface. That is wrong, because in the question it is mentioned that the plate is heated to the high temperature. So the object is heated equally at every point. Therefore option D is also wrong. Question 20. Explain about the emission. Question 21. A water wave passes into a region where the wave travels more slowly. As it passes into slow region, what happens to the frequency and what happens to the wavelength of a wave? So it's as already mentioned, when the wave passes to slow region, that means the velocity will decrease. What happens to the frequency and what happens to the wavelength? So first we can think about frequency. We need to know that for a water wave, frequency is decided by the source which produces the wave. That means how many waves that source produce, that is frequency, or how many waves produce in 1 second, that is frequency, and which is only depending on the source. Source of water wave, doesn't matter the water speed is more or less, it's not going to affect the frequency. So that we can conclude that the frequency will remain same throughout the motion, doesn't matter speed is greater or lesser. Next, about wavelength. What will happen to wavelength when the speed decreases? To check that, we should use the equation, wave equation, that is speed of a wave is the product of its frequency and wavelength. And we have already seen frequency will remain same, but in this particular case the velocity decreasing, and in order to maintain the frequency same, definitely the wavelength of the wave will reduce. So now we can check which option is correct. As we have already discussed, the frequency will remain same. So it will be either option C or D. And we have already seen that the wavelength will decrease. So the correct answer is option C. Question 22. Light traveling at a speed of 3 into 10 to the power 8 meter per second strikes the surface of a glass block and undergoes refraction as it enters the block. The diagram shows a ray of this light before and after it enters the block. So we are provided with the angle of incidence and angle of reflection. We need to calculate what is the speed of light in glass. So in order to find the speed of light in the glass, I am representing it with Vg, speed of light in glass. We can use the equation of refractive index. That is, refractive index is the ratio of the speed of light in air or vacuum divided by speed of light in that medium. Here we have glass. So this is the refractive index equation. And there is another equation for refractive index, that is M refractive index is sine of the angle of incidence over sine of angle of refraction. So both are the equation of refractive index. So we can equate the RHS of both the equations. So we will get speed of light in vacuum over speed of light in glass will be is equal to sine of angle of incidence over sine of angle of refraction. So in this question we are provided with the speed of light in the air is given, I is given, angle of incidence and angle of refraction is given. So we can substitute. So just substitute the value. C is 3 into 10 to the power 8 over speed of light in glass is equal to sine 55 over sine R. So therefore 3 into 10 to the power 8 over Vg, sine 55 over sine R is 33. So when you substitute you will get this is 1.5. In order to calculate Vg, make Vg as the subject, or you can take Vg to the right hand side and take 1.5 to the left hand side. So you will get Vg is 3 into 10 to the power 8 over 1.5. So the correct answer is 2 times 10 to the power 8 meter per second. Therefore the correct answer is option B. Question 23. A beam of light is monochromatic. What does monochromatic mean? So monochromatic means the light wave which consists of only one color. So in monochromatic light all waves will have same frequency. So the air amplitude can be different also. Therefore the correct answer is option A. All the waves in a beam must have the same frequency. That is how we can describe a monochromatic light. Question 24. An object is placed in front of a thin converging lens. The diagram shows the path of two rays from the top of the object. An image of the object is formed on the screen to the right of the lens. How does this image compare with the object? So in order to check the property of the image formed from this diagram, we need to extend these rays. So you need to take a ruler and first extend this ray. Using a ruler, it should be straight line. Likewise, we can extend the other ray, the ray which is passing through the center of the lens, which won't deviate but this will move straight. So any ray which is passing through the center of the lens will always move straight without any diffraction or deviation. So we can complete the second row by extending it with a ruler as a straight line. So these are two rays. The path of two rays when we extend we can see, and we can check where these points, two rays are meeting. This is the point where two rays are meeting. Here the image will be formed. So we can just draw a straight line from the principal axis. So this will be the position and the size of the image, and its direction is downward or inverted. So the image of the object will be formed here. Now we can check the characteristics of the image. Comparing to the size of the object, the image is larger. So that is the first point. Image formed is larger. And the second point, it is inverted. As you can see, the object is upright but the image is inverted. So that is the second property, that is inverted. The image is inverted. Now we can see the options. Option A says the image is larger and inverted. That is true. Therefore correct answer is option A. Anyway, we can see other options. Option B says it is larger. That is correct. And the same way up. No, it is inverted, upside down. So option B is wrong. Option C says it is smaller and inverted. It is inverted but it is larger, not smaller. Option D says it is smaller. Again, that is wrong. And the same way up. Both the points about option D is wrong. Therefore, correct answer is option A. Question 25. Which row correctly describes what happens to the frequency and to the speed of electromagnetic wave as we move through the spectrum from gamma ray to radio waves. In order to answer this question, we need to know what will happen to the frequency of electromagnetic waves when it is moved from gamma rays to radio waves. We can look at the electromagnetic spectrum. So as you can see in this spectrum, the gamma rays, the wavelength is very less, or there are more number of waves, so the frequency is more where the wavelength is less. But when we are going from gamma rays to radio waves, we can see the wavelength is more as the distance between peak to peak is very high. So the frequency is just opposite of the wavelength, and the frequency or the number of waves produced will be less. So we can understand when we think about the frequency, as it is moving from gamma rays to radio waves, its frequency is more at gamma rays range and less at radio waves range. So the frequency is decreasing. Next, we can check the speed. The speed of electromagnetic wave is constant, or any electromagnetic wave, whether it is gamma, X-ray or radio or any other electromagnetic waves, the speed of electromagnetic wave is a constant value, and that is 3 into 10 to the power 8 meter per second. So we can understand the frequency decreases but the speed remains same. Therefore, the correct answer is option B. Question number 26. The diagram shows a model of sound wave passing through air in an open tube. What is the region Q? So when we observe the region Q, we can understand there less number of particles are present, and if the particles are less, definitely the pressure will be low, because pressure is nothing but the force due to the collision of the particles. When the particles are less, the collision will be less, therefore the pressure will be less. And these parts of a sound wave where the particles are less or pressure is less known as rarefaction. Therefore, in order to answer this question, what is the region Q? It is not compression at all. Compression is the region where pressure will be maximum. So it is a rarefaction, that is correct, but the pressure will be less. But in the option C it says high pressure, wrong. Rarefaction where the pressure will be low. Therefore, the correct answer is option D. In 27, the sound from a loudspeaker must pass through two materials to reach a microphone. Which combination of material gives the sound shortest time for the sound to reach the microphone? So we need to check which combination of materials will allow the sound wave to pass faster. So here we need to find through which material the sound can travel faster. So we have the options here: air, liquid, that is water is a liquid, and solid. Copper and aluminium belongs to solid. So when we check the speed of sound, which is most in solid, so we can understand velocity or speed of sound in solid is very high. Then the speed or velocity of sound in liquid, and the least speed the sound will have in air. So the velocity of the sound in air is least. So when we see the options, we can see copper and aluminium both are solids, so the sound will travel faster if we use these two metals are material 1 and 2. Therefore, the correct answer is option C. Question 28. A bar magnet picks up two steel balls. Which diagram shows the magnetic poles induced in the balls? So we can look at option A, where you can see the south pole of a bar magnet is attracts to the south pole of a steel bolt, which is not possible. As we know, only the opposite poles attracts, but here south and south are same poles, so they will only repel. Therefore option A is not possible. Let's look at option B, where this again, when we look at the south pole of the bar magnet is getting attracted to the south pole of the bolt, which is again not possible, as opposite charge only attracts and same charges will repel, not attract as seen in the option B. Let's look at option C. In option C, the south pole of the bar magnet gets attracted with the north pole of the bolt, which is possible, but the south pole of the bolt is attracting with the south pole of the next bolt. That is not possible. Here it must be repelling. So option C is also wrong. Let us look at option D. In option D, the south pole of the bar magnet attracts with the north pole of the first bolt. That is possible, as they are opposite poles, they will definitely attract, and the force between the bolts, where the south pole of the first bolt attract with the north pole of the second bolt. This is also possible, as they are opposite poles. Therefore the correct answer is option D. 29. A student rubs a plastic rod. Question 29. A student rubs a plastic rod with a cloth. The rod becomes positively charged. What has happened to the rod? So we have a plastic rod. When it rubbed with a cloth, it becomes positively charged. That means it must have lost some electrons, because protons that have positive charge cannot move from an atom. So the protons cannot move, but only electrons can move. So as this rod has become positive charge, means it must have lost some electrons or negatively charged particle, that is electron. So because of this loss of electrons from the rod, definitely the rod will become positive charge. So this is what happens. Any object which become positively charged means it has lost some negatively charged electrons. Let's see the options. Option A says it has gained electrons. If the rod has gained electrons, then the rod will become negative charge, but here the rod become positive charge. That means option A is wrong. Option B says it gained protons. I already mentioned the protons cannot move from one object to another object, because they are bound inside the nucleus. They cannot move outside. So never protons are going to gain or lose. So this is also wrong. Option C says it has lost electron. That is correct. The electrons can move from one object to another object. So the rod has lost electron. So the total charge of the rod will become positive. Option D says it has lost proton. As we have already discussed, protons can neither gain nor lost. It can stay only in the same place. Therefore the correct answer is option C. Question 30. An isolated metal sphere is positively charged. It is then brought near to another isolated metal sphere that is neutral. What happens to the charges on the neutral sphere as the positively charged sphere is brought close to it? So when this positively charged sphere bring close to the neutral metal sphere, initially the metal sphere will have equal number of protons and equal number of electrons. But when this positively charged sphere come close to this neutral metal sphere, all the electrons in the metal sphere or the neutral material will come close to the positive charge because electrons can move freely. So electrons present at the right side of the sphere will also come to the left side of the sphere, but proton will stay in the same place. But you can see the electrons will move towards the left, that is close to the positive charged sphere, as the electrostatic force of attraction between opposite charges. This is what happens. So we can check the options now. Option A says some positive charges move to the left, but we already discussed positive charges cannot move. Positive charges means these are due to protons, and protons cannot move, they can only reside inside a nucleus. So option A is wrong. Option B, some positive charges move. Again, that is wrong. As we discussed, positive charges will never move. Option C says some positive charges move. Again it is wrong. Option D says the positive charges do not move. Yes, this is a correct statement. But some negative charges move to the left. Right, that is nothing but electrons. The negative charged particles, electrons can move, and all the electrons will move to the left where we have kept the positively charged sphere. So the correct answer is option D. 31. The diagram shows a circuit containing a cell, 2 resistors, a switch and a voltmeter. When the switch is open, the voltmeter reads 1.5 volt. When the switch is closed, the voltmeter reads 2 volt. What is the electromotive force of the cell? So we need to find what is the electromotive force of the cell with the help of given clues in the question. We can simply use the second point given in the question in order to find out what will be the EMF or voltage of the cell. So as mentioned in point 2, that when the switch is closed, the voltmeter reads 2 volt. That means when the switch is closed, we can see what will happen to the current. So the current will flow from the positive terminal of the battery, as we know. When the current reaches at the first junction, it has 2 paths. But in one path there is a resistance, but in the other path there is no resistance. So all the current will choose the path there is no resistance. This is a property of a current. If there are 2 paths and in one path there is no resistance and another path there is a resistance, then the current will flow only through the path there is no resistance. So once the switch is closed, for the current there is a path without any resistance. So the current or all the current will follow that particular path. So there won't be any current following through the resistor. Once it reaches at the second junction, again it has 2 paths, but the voltmeter resistance or the resistance of voltmeter is very high, so that no current will flow through the the voltmeter. So whatever the current reaches here, then it cannot pass through the voltmeter, as voltmeter resistor is infinity. So all the current will pass through this single resistance and it will go to the negative side of the cell. So this is the path of the electric current when the switch is closed. Now by looking at the circuit, we can clearly understand there is only one resistor in the path of current here, and that is this resistor where we have kept the voltmeter. So the voltage drop is happening only at this part of the circuit, as this is the only resistor available in this particular flow of electricity. And during this time, what is the voltmeter reading? It is given that is the voltmeter reading is 2 volt. So we can understand the only voltage drop is across this resistor at this particular scenario, and at this time 2 volt is the voltmeter reading across this particular resistance. So that will be the whole voltage provided by the cell, because this is the only place there is a voltage drop happening in the circuit. So definitely the same amount of voltage the cell must be producing. That means the EMF of the cell or the voltage of the cell is 2 volt. Therefore the correct answer is option C. Question number 32. A 4 ohm resistor and a 12 ohm resistor are connected in parallel. What is the effective resistance of this combination of resistors? So these resistors are connected in parallel. In order to find the combined resistance, we can use the equation, that is 1 over R total or R combined is equal to 1 over first resistance plus 1 over second resistance. So we can substitute the values. 1 over RT will be 1 over first resistor value is 4 ohm plus 1 over second resistor value is 12. So we will get 1 over RT is equal to 0.3333, and in order to find out RT, that is the combined resistor, we have to take the reciprocal at both the sides. Therefore 1 over RT reciprocal is RT, that will be 1 over 0.333, and the answer is 3 ohm. Correct answer is option B. Question 33. Which combination of two gates will result in the truth table shown? So let's look at the logic gates of each option. So in first option we have combination of a NAND, its output connected to a NOT gate. So let's look at the truth table of a NAND gate. So for NAND gate we have two inputs, input 1 and input 2 and one output, and the possible inputs are 0 0, 0 1, 1 0 and 1 1. For NAND gate the outputs for these input combinations are 1 1 1 0. This one you are supposed to learn already. Likewise, these outputs of the NAND gate we are connecting to the NOT gate. So we can see what will happen when you connect this output to a NOT gate. Then you will get opposite of the values which you are already getting at the output of NAND. So the 1 will become 0 when you NOT it. Again 3 1s are there, so 3 1s output will be 0 when you NOT, and the 0 will become 1. Therefore the truth table of this combination is, when we give the inputs, these inputs, the output must be 3 zeros and 1. But here the output is only 1 0 and 3 1s. So the first logic gate combination is not representing the truth table given. Now we can look at the option B, where we have a AND gate and a NOT gate. So we can see the truth table of an AND gate first. So when we look at the AND gate, it will have definitely 2 inputs and 1 output. So let's see what will be the output. So the possible input combinations are 0 0 0, 1 1 0, 1 1, as same given in the question truth table. For this, the output of a NAND gate is 0 0 0 1, and in this option also we know that AND gate output is connected to a NOT gate. So we can again see what will be the output of the NOT gate, as you have connected NOT gate also here or at the output terminal of AND. So we will get 1 1 1 0, but we are supposed to get not 1 1 1 0 but 0 1 1 1. Therefore option B is also not representing this input or this given truth table. Now we can look at option C. So in option C we are provided with a NOR gate. Output of a NOR gate is connected to a NOT gate. So let's check what is the truth table of a NOR gate. So again we will have 2 inputs, input 1 and input 2 and output. For the NOT gate, again the possible inputs as shown in the truth table is 0, 0, 0, 1, 1, 0, 1, 1, and output of a NOT gate is 1, 0, 0, 0. And again the NOT gate's output again connecting to a NOT gate. So let's see what will happen if we connect this output to the NOT gate. So we will get just the opposite value. So we will get 0, 1, 1, 1. So we can see the output for the option C logic gate combination is 0, 1, 1, 1. And in the given truth table also we are getting the same output at R. That means the logic gate given in option C represent the truth table given in the question. Therefore the correct answer is option C. Question 34. A solenoid is connected to a very sensitive ammeter. A rod is inserted into one end of the solenoid. The ammeter shows that there is a small electric current in the solenoid while the rod is moving. Which rod is being inserted? So actually when the rod is inserting into this solenoid, in order to have a reading on the ammeter, there must be a current produced when the rod is inserting. That means there must be a induced EMF generate while the rod is inserting. So this is an example of electromagnetic induction. Or we can understand that when the rod is inserting, as the ammeter is showing some reading, there must be electricity generating. It is only because of the process of electromagnetic induction. So electromagnetic induction is happening here. Now in order to occur an electromagnetic induction, what material this rod should be made of? So we know that electromagnetic induction is a property in which the electricity generates when the magnetic field lines are cutting off. In order to have this rod must be a magnet. If it is a magnet only, when it inserts inside the solenoid, its field lines will get cut. As a result, there will be a induced EMF generate, or there will be a current generating. As a result, the ammeter will show some reading. So the condition for this is the rod must be a piece of magnet. Now we can look at the options. Which option says the rod is a magnet? And we can directly see it's option B, which says the rod is a magnetized steel rod. Then only the field lines will cut when it inserted in the solenoid, and it will produce a current due to the result of electromagnetic induction. Question 35. A 12 volt 36 watt lamp shines at normal brightness when connected to a main transformer. Assume the transformer is 100% efficient. Which row shows the number of turns in the secondary coil and the current in the main wires? So in this question we are provided with the number of turns in the primary, that is 1200 turns. Then the voltage at primary Vp is also given, that is 240. Then at the secondary side or the output side of the transformer, we are provided with the voltage, that is 12 volt. That means the voltage at secondary Vs is also given, that is 12 volt. So we can find out the number of turns in the secondary using the equation Ns over Np is equal to Vs over Vp. So in order to calculate Ns, that is the number of turns in the secondary, Vs over Vp is already there at the right hand side, and we can take the Np also from left hand side to right hand side. Here basically we are just making Ns, number of turns in secondary, as the subject. Now we have the values of Vs, Vp and Np. We can substitute. Vs is the voltage at secondary, that is 12 volt over Vp, voltage at primary is 240, times number of turns in primary is 1200, and the answer is 60. That means the number of turns at secondary is 60. This is what the first thing we need to calculate from the question. So the number of turns is not 180 but it is 60. Next we need to calculate the current in the main wires. So main is at the primary, as it is already mentioned. AC main lies at the primary terminals of the transformer. So here we need to find what is the current flowing through this main coil or the coil at the primary terminals. We have the voltage at the primary terminal, that is voltage is 240, and we have the power at the secondary terminal. We don't have the power at the primary terminal, which is not given, but the power at the secondary terminal is given. But we know that as the transformer is 100% efficient, whatever the power at input will be same as the power at output. So even the power at the input terminal of the transformer will be same as the power at the output terminal. So the power at input terminal will be also 36 watt. This one we can conclude only the transformer is 100% efficient only because of this point given in the question, that the transformer is 100% efficient. We can take the same value of power at the secondary as same in the primary also. So now we have power also, that is 36 watt. Now we have voltage and power. We need to calculate current. So we can use the equation which link voltage, power and current, that is power is the product of voltage and current. From these, in order to calculate current, we can make current as the subject. So we will get power over voltage, where power is 36 over voltage is 240, and the answer is 0.15. Therefore we have the number of turns is 60 and the current in main wire is 0.15. Therefore the correct answer is option A. Question 36. Diagram 1 shows a wire carrying an electric current into the page. The wire is between the poles of a magnet. A force is produced on the wire acting downwards the bottom of the page. Diagram 2 shows the situation after the current is reversed and the magnet is turned through 90 degrees. So in diagram 1, the direction of current flow was into the page. That means in diagram 1 the current is flowing into the page, but in diagram 2 the current is reversed. That means the current is flowing out of the page in the second diagram. And even the magnetic field direction also changed. In which direction does the force act after these changes in diagram 2? So we have the direction of current which is out of the page. The current flows out of the page. And when we look at the magnetic field direction, as the direction is always from north pole to south pole, the magnetic field direction is upwards. That is the direction of magnetic field in diagram 2. So we have magnetic field direction and we have current flow direction, and we need to check what will be the direction of the force. So here we have to use Fleming's left hand rule, because in this question current is already there, force is the output. So in order to check what will be the direction of force, we have to use Fleming's left hand rule. But in some questions force will be already there, or the force will be the input along with the magnetic field and the output will be current or induced EMF. In such cases we have to use Fleming's left hand rule. In that case we have to use Fleming's right hand rule. But here the current is already there, current is not generating, only the force is generating. In such cases we have to use Fleming's left hand rule. So when we use Fleming's left hand rule, we have to focus on three fingers. The first one is the third finger that is the middle finger, and which represents the current flow direction. So you should point your third finger in the direction of the current flow, and the second finger or the index finger which represents the magnetic field direction. So we should point the second finger according to the direction of the magnetic field. Then the third finger, that is actually the thumb. Thumb will point into the direction of the force. So this is Fleming's left hand rule. This is how we have to point our fingers. Now we can look at the question. In the diagram 1 we have the output, the current direction which is flowing out of the page. That means the current flow should be represented with the third finger. So your third finger should point out of the page, or it should point towards your face. Next one, you know the direction of magnetic field which is moving upwards. So that the magnetic field which must be represented with the second finger, which you should point, or your index finger you should point in the same direction of the magnetic field, and here it should be pointed upward. As you can see in the figure, the magnetic field is from north pole to south pole, so that it must be upward direction. So now what you have to do is keep your third finger or middle finger out of the page or facing towards your face, and the second or index finger upwards. Then check what is the direction of the thumb, and you can understand your thumb will be pointing towards the left hand side of the page. So therefore the correct answer is option C. So here when you apply the Fleming's left hand rule, your second finger or index finger will point upwards and the third finger should point towards your face. Then you can see your thumb is pointing towards left. So this is thumb. Sorry, my drawing is so poor, but I hope you can understand. Question 37. The charge on a proton is E. What is the charge on an electron and what is the charge on a neutron? So we know that a proton has a positive charge and electron negative, but neutron has no charge. So if we represent plus E or simply E, that is a positive E for proton, we can represent negative E for electron. And for neutron, as it has no charge, we can represent as 0. Therefore, option D says these things, that electron will have negative E and neutron will have 0. So the correct answer is option D. Question 38. The diagram shows alpha particles incident on a thin metal foil. How does the motion of these particles give evidence for the nuclear atom? So we have here a thin metal foil and alpha particles incident on this thin metal foil. Once they incident on the metal foil, what happened to their path? We can see that clearly. Most of the alpha particles are moving without any deviation. Only few alpha particles are deviating with less angle and very less number of alpha particles. Even here only one alpha particle is reflecting more than 90 degree, or they are reflecting back. So how does the motion of these particles give evidence for the nuclear atom? So this is similar to the Rutherford's alpha particle experiment. Let us look at each options. Option A says most alpha particles passing through with minimal deflection shows that the atom is mostly empty space. And this statement is correct, as we know that the alpha particle is positively charged particles and the nucleus is also positive. Nucleus in an atom is also positive. But when this alpha particle reaches and strikes at the nucleus, as positive and positive repels, they are supposed to deviate. But this deviation is very less happening in this process. That means the nucleus residing in a very less space. Or we can conclude the most of the space in an atom is vacuum or empty spaced. So that the correct answer is option A. Question 39. Radium-226 is an alpha emitter. It is implanted inside cancerous tumors. It is safe to use as it kills the cancerous cells but not the healthy ones surrounding the tumors. Which properties of alpha particles compared to other emissions enable this use of radium-226? So, the radium-226 we can use to treat the cancerous tumors, and the radium-226 is the suitable atom or element which will kill the cancerous cells but not the healthy ones surrounding the tumor. So we need to mention which property of alpha particles compared to other emissions enable this use of radium-226, or why we are using the radium as it emits alpha particles, or why we can use alpha particles for the better treatment. So the reason is the ionizing effect of alpha particles is very high and the penetration of alpha particle is low, so that it won't penetrate to the other body parts or organs. But it is having a very high ionizing effect. That means it can kill all the cancerous cells using its high ionizing effect. But it cannot penetrate to the other healthy body organs because its penetration power is low. So that the correct answer is option B. Question 40. The graph shows the activity of a radioactive source over a period of time. So the activity and time graph is shown. What is the half-life of the source? So what is half-life? Half-life is the time taken to reduce its activity exactly half. So initially its activity is 120. Now the half of 120, that is 60. So we need to check what is the time taken in order to reduce its activity from 120 to 60. So we can look at the graph. Initially this was 120 and when it reaches 60, that is this point represents 60 activity. So in order to change from here to here, what is the total time taken? From 120 to 60. So this is the time taken, and that is we clearly seen it is 2 minutes. Therefore the correct answer is 2 minutes. Thank you for watching the video. If you like this video, please subscribe my channel. Thank you.